Next up, we're going to stay in the math area, and I'm going to call up Dr. Farnum to talk a little bit about what he does.
Hi everybody, good to see you again. My name's Edward Farnum, and what I do differential equations, optics, and computation. So I look at things in the intersection of mathematics, physics, and computer science to some extent. The things that I'm interested in is the propagation of trains of optical pulses, what you might use to transmit your messages through the internet, for instance. And as it turns out, the mathematics of this is an awful lot like the behavior of water waves at the ocean, or even to some lesser extent, sound waves. So I'm a waves person, and what I typically do is I say, what are the characteristics of this particular laser system, and how can I capture them in a mathematical model? And then once I have such a mathematical model, when does it break? So I'm always trying to break my models, because it's an awful lot cheaper to break a piece of mathematics than it is to break any actual physical equipment. So if we can break it or find out when it breaks in a mathematical model, we don't have to worry about the physicist or the engineer breaking his very expensive piece of machinery. So the kinds of things that I have my students doing is running differential equations, running simulations of differential equations on a computer. That's probably what my students do, especially their first year, but I've even had some high school students do it over the summer. And then after a little while, along the same lines as what Dr. Joyner was talking about, we start thinking of dimensional reduction. What are the characteristics of this model that I can reduce? Can I change this model to go from being a simulation that takes 5 or 10 minutes to run down to a simulation that can run in 1/100th of a second? And if I can, typically I can also understand this thing in a much simpler fashion as well. So if you like physics, if you like programming, if you like math, or any combination of those, that's the kind of stuff that I do, and I would be interested to talk to you later, and maybe you'll come see me this summer, or maybe you'll come to join the program in a year, and I would love to have students come join my group as well. So, thank you.